So here we have the Raspberry Pi out here. All right, so this was connected. If you remember, this was connected to pin number 1 before. In the earlier program, this was connected to pin number 1 where the LED was always on. But now we have programmed pin number 7. So let's count it out: 1, 2, 3, 4, 5, 6, 7. So go to pin number 7 and just connect it. Since you've already programmed pin number 7 and you've programmed it for blinking for every 0.5 seconds, there you have the output for blinking. So you have the anode connected to pin number 7, and then you have the cathode via the resistance. After the resistance, that particular wire is then connected to the particular pin that is ground. All right. So with this, of course, we have finished the blinking program. We'll also have a look at how to get an input from the user. That means how to get an input using an input sensor. So, just like LED is an output device, you can keep giving outputs to the LED. Same way you have an input device. Let's say the input device is called as, okay, we are going to use an input device called as a button. So just a second, I'll just show the button to you. And maybe we'll just have a look at how the button works. And then we go on to a few more coding out here. Okay, so here is, just a second, I'll just take it out for you. Okay, so here is a button, this is the push button that we're going to use. So that means when we press, it's going to give a particular output. When we leave it, it's going to give you a particular output. So we're going to have a look at the button. Okay, for now, let me make you understand how a button would work. Let me just connect the button, by the way, onto the breadboard. So this is the button. I'll connect it to the breadboard such that, two of its legs are on, it's a 4-legged button. So 2 legs of it are on the, 2 of the vertical lines, which are at the bottom, and the other 2 legs are on the other, this vertical lines, 2 of the other vertical lines on the upper side. So you can use it and then press it inside. So it will go into the breadboard and it will be stable out there. Now on this particular breadboard, what we can do is we can use this particular button to press. We can press the button or we can leave the button. Now what exactly happens when we use the button, or what is the procedure, or how does the button act like? So the acting of the button is such that, when you press the button, these 2 pins, which are connected on 2 vertical lines out here, these 2 pins out here, they get internally shorted inside the button. So that's what happens when you actually connect a particular button, right? That's what happens. Now comes a question. All right, if this is what happens when you do it, how do I make my button give an input to my Raspberry Pi? See, remember, the Raspberry Pi pins can only understand a high voltage or a low voltage. It can only understand whether the voltage has gone above 3.3 or whether it is 0. That is all that the Raspberry Pi can understand, right? So if the Raspberry Pi can understand only that much, first of all, this button, does it have any electrical power by its own? No, it's a passive sensor. It cannot produce electricity on its own, nor can it give a high and a low on its own. We need to do something to it such that it is able to give a high and a low. Okay, it is able to give a high and a low, in such a way. So how do we make that possible? We can make it possible. Okay, for now, you can just take it as a fact, but then the minute you start doing it yourself currently, you'll understand, oh, this is how it works. Okay, so let's say I connect my resistance. I connect the resistance to one vertical end of the button. So I connect a resistance to one vertical end of the button. The second one, I just connected it to a random horizontal line, which I'm going to connect it to, which I'm going to say that is going to be my ground. Now I already have a ground here. Which is connected to the resistance of the LED. So what I'm going to do is I'm going to take that ground out and I'm going to put it at the bottom. And even this resistance, which was connected to ground, if you remember, this resistance is connected to ground. That resistance I'm going to, bring it to the bottom such that the ground now is common for this resistance as well as this resistance. Both of them required a ground, and I gave them a common ground. Okay, so that's how I made the connection. I made a common ground for resistance 1 and for resistance 2. But now comes the question. All right, so you have connected the LED, you have connected the resistance to the button, and the button is now, as you can see, the button over here, the button over here, one end of the button is connected to resistance. Now, what can be done such that the Raspberry Pi can do something intelligent? Okay, can do something intelligent or can detect something intelligent. Okay, what can be done? We'll just have a look. All right, what can be done? First of all, the button is given, one end of the button is connected via resistance to ground. Second end of the button, second pin of the button is going to be connected. I'm going to connect this particular pin. I'm going to connect it to, let me connect it to a 3.3 volt. I'm going to connect it to a 3.3 volt. So I connect it to a 3.3 volt. So my first end of the button is, one end of the button is connected via resistance to ground. The second end of the button I connect via the, second end of the button directly I connect it to the first pin, that is a 3.3 volt. Okay. Okay. So now, sir, exactly what are you trying to do? Basically what I'm trying to do is, I'm trying to connect a button in such a way that I'm able to, deal with something in such a way that I can create a, I can now make the button give a high and a low. Okay, how? I can use the property of the button to give a high and a low. Now let's understand. The minute you press the button, what happens? These two get shorted. Now let's consider the case when it is not pressed. When it is not pressed, what is the voltage at this end of the button? 3.3 volt. Okay. What is the voltage at this end of the button? This end of the button. It is going to be ground. Yes or no? Because the resistance is, via the resistance it is connected to ground. Right? It is going to be ground. Now, is the circuit complete yet? This is a 5 volt. There is a ground here, but is the circuit complete? No, the circuit is not complete because this is an open circuit for now. It is open when the button is not pressed. But the minute you press the button, what happens? These two get shorted. Even this particular pin becomes 3.3 volt. This 3.3 volt travels via the internal shorting to this particular pin, and this pin becomes 3.3 volt. Whereas now this pin of the resistance, this side of the resistance is still ground, but this pin is not ground anymore. This pin is 3.3 volt. Are you able to understand? So this pin, when the button is not pressed, this side pin of the button, that is to, hope you're able to visualize this and hope you're able to see it. This particular pin is going to be given a 0 voltage when it is not pressed. Okay. But the same particular pin, when the minute you press it, because of the internal shorting, the same pin is going to give a 3.3 volt. It is going to give a high voltage. So can I tap this particular pin? That is the pin which is lying, the pin of the button which is lying between the resistance and the 3.3 volt. This particular pin between, this particular same line where the resistance and the button pin is connected to the same line. That particular line can be used for what? For giving, when the button is not pressed, this particular line is going to give a 0 volt. But when you press the button, this particular line will give the Raspberry Pi a 1 volt. Are you able to understand? So I can actually tap that particular line. So how do I tap it? Let's tap it by using a particular wire out there. Put a wire into that particular line and then connect that particular wire to let's say to pin number 1, 2. you can connect to any one of the GPIO pins. So let's say we will use GPIO 18. GPIO 18 is pin number 12. Okay, or we'll use pin number 11. Pin number 11, board number, pin number 11. That is GPIO 17, pin number 11. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I'm going to connect this to pin number 11. Because now, this particular line, when it gives to the Raspberry Pi a high, the Raspberry Pi should read a high on pin number 11. When you press the button, when you press the button, it will give a high. When you don't press the button, it will give a low, and the Raspberry Pi will read the button value that is a low. It will read it on which particular pin? On pin number 11. Hope this is very clearly understood. Okay, so we'll understand a little more. So maybe you might not understand the full gravity of it currently, but the minute you connect it, you will understand it better. So let's understand the connections, and you please do the connections along with me. So the button is connected onto the breadboard, and two ends of the button are used. The above two ends are not used. Okay, one end of the button is connected directly to 3.3 volt. The second end is connected via the resistance to ground. But the end where the button and the resistance meet, that particular end, somewhere in the middle, this particular end is taken to a GPIO pin of the Raspberry Pi, and the GPIO pin is pin number 11. Okay, hope that is clearly understood. We'll go forward from there and start programming on how to take an input from the button. Okay, is that very clear? All right.